Not a single one of these has a squared in it. So I'm not using these identities on this one, at least not to start. I'm using these ones. Is everybody with me so far? All right. And that sign x, do I have any of these that have sign is equal to something? No, so let's not do anything to the sign. Same with the cosine. What about the secant? Can I do anything with secant?
You could turn it into 1 over cosine.
I could turn the secant into 1 over cosine. And every time I do this, all I'm doing is replacing equivalent values. I'm taking out two things. I'm taking out one thing and replacing it with something that is equivalent to it. What about that cotangent? I could do 1 over tangent, but one of the things that's going to be really helpful is this, if we see that so far all of these are in sines and cosines, cotangent also equals cosine over sine. So I'm going to, instead of using 1 over tangent, not that that was a wrong idea, instead I'm going to use cosine over sine. And then from here we can say, all right, now what? What's up, Theo?
Can we cross multiply the 1 divided by cosine and
So,
cosine sine?
say that again?
So the 2 on the right, you do 1 times sine to get sine, and then cosine times cosine would be cosine x squared.
So you want to multiply across?
Yes.
Yeah, I'm not going to do that. We could do that, but I'm not going to do that. To me, whenever I have an opportunity to make something simpler, I'm going to do so. And I see some opportunities to make something simpler here. Yeah?
Can't you cross out the cosines?
Yeah, if I have a cosine on top and a cosine on bottom, I'm allowed to cancel them with each other if they are being multiplied. This is why it's better that these are being multiplied than being added. Yeah?
Why didn't you cross out both of the cosines in the fraction?
So you can it's got to be a 1-to-1 thing. So you can once this cosine is crossed out, I don't have another cosine to cross out.
I'm saying, why didn't the one on the left? Why didn't you do one?
So you're saying I could have done that and I'll get the same answer. Did that answer your question?
So you just didn't teach better the
I just did the first one I saw. This one cosine can only cancel with one cosine on the top. And either way, I'm going to have one cosine left over on the top. And it doesn't really matter which one I cancel it with. Okay? Once I cancel those cosines, knowing I can cancel those cosines, what else can I cancel out? The sines. So what's my final answer? Cosine of x. If you said 1 cosine x, cool. I don't care. That's the same thing. Yeah, Theo.
Wouldn't the 1 be canceled out though? Because it's not.
So one's a one times something divided by 1. 1 is one of those special numbers that if you write it, it's fine. If you don't write it, it's fine. Like there's no difference between 1x and x. There's no difference between 1 cosine x and cosine x. How are we feeling so far?
I feel like I understand it, but don't understand it at the same time.
That's fair. I think that's a reasonable way to feel right now. Yeah.
I feel like it's mostly just finding stuff and then crossing stuff out.
If you can, yeah.
I feel like I would be happier if I just instantly.
Cool.
Valid point.
I feel like I understand it when it's multiplied like that, but when it's like anything else, I don't understand it.
Yeah,
You know what we should do is like,
only make it
since we only want multiplication, that's the only place we feel comfortable. We should put some more practice in at one of the other areas. Like, I don't know, a division question. Let's look at this one.
with the division. Can't we just like change it to multiplication though?
We can. Like can we just change it to multiplication? No, but could we change it to multiplication in an equivalent form? Yes. So when you say, can I just change it to multiplication? That answer is no. But can I change it to multiplication? Yes, and we're going to. All right. So, you guys, what if I, instead of writing this way, I made this secant times 1 over tangent? Wouldn't that be the exact same thing?
Yeah, probably.
To just split it up? And then the minute I do that, what do I know about 1 over tangent?
It's equal to cotangent.
It's equal to cotangent. Cool. So it's starting to feel a little bit better, right?
Cotangent is equal to cosine over sine.
Cotangent is equal to cosine over sine.
And secant equals 1 over cosine. 1 over sine. Sorry.
I'm going to listen. At this point, I'm going to listen people think and process what just happened before I do anything else, if that's okay with you.
I'm confused. How did we get cotangent? Okay, so we're like jumping through like previous there.
Yeah, don't worry. There's only about 50 different ways. I changed the attendance. Yeah, because I changed the attendance. Yeah. Yes. Yes.
Are you sure you changed?
Wow, no goodbye or anything?
She hung up on me. It was Mrs. Berlin. She hung up on me. She's like, okay, thank you, and hung up the phone. What was I supposed to do? Bye to the dial tone I just got?
But are you sure you changed the attendance?
Yeah.
Are you sure?
You should double check.
Does anyone want to talk about any of the steps yet?
No.
Is there anything you're like, I hate this? I mean, no. So, no. I want to rephrase that. Is there, because I think I know the answer to that question. Is there anything that you guys are like, that doesn't make sense to me? Yes, Dylan.
The first step where you made it 1 over tangent, how did you do that?
She just split up the
Like, how do you flip it when it's...
I didn't, I just, I got it. Okay, can I put an invisible 1 there? And that would make sense to you? And an invisible 1 here? And then I just split it up into the 2 pieces.
Oh, okay.
Does that work?
Why is it multiplying?
Yeah, but when you
'Cause-
cancel the ones...
Sure. But you would still have a tangent on the bottom, right? So Dylan, I tell you what, in 2 minutes, I'm going to work this a different way for you and see if it makes more sense to you. Does that work?
Yeah.
Okay. You guys, would somebody like a different approach? Yes, Cody.
I think I might know that different part, because I was about to ask, couldn't you turn tangent into sine over cosine, then flip that, and then get the answer?
That's close to what I'm going to do. Yes. Yes.
Okay, so like just the idea of like 1 over tangent x and just like reversing that is just like, I don't know, I just don't really like think in that way.
Yeah, I see that.
Yeah.
Okay, so you know what I'm hearing, you guys? I'm hearing that you guys want to see a different approach.
Yes.
Yes.
Okay. So you guys, there's my original fraction bar. So I want to focus on first secant of x. How can I rewrite secant of x?
1 over cosine.
1 over cosine.
That's what I did. But I don't know.
Okay? And on the bottom we have tangent of x. How can I rewrite tangent of x?
Sine over cosine.
We still good? And when I'm dividing, are we good with that flip and multiply step? So really, I can change this into 1 over cosine x times, but then I got to flip this, right? Because I'm going from dividing to timesing, and I end up with cosine x over sine x. Does that make sense? You're more comfortable with that approach? Because it's getting us to the same place, two different thought processes. This is actually one of the things I love about trig identities, but I can see how in the first time dealing with them, situation where you guys are versus someone like me who's been dealing with them for 20 some years, it is a different. But here's a great thing. The fact that there's different approaches is easier for you and more challenging for me because I can still follow your work to how you got there. I don't care which approach you take. Either way, now that we've gotten to this step in either with both approaches, do we see anything else we can do? Cancel out the cosines? I have a 1 on top and a sign on the bottom. And I would appreciate it if you guys put that as cosecant x. But if you left it as 1 over sine, you're getting 99% of the way there.
Are these gonna be up here tomorrow?
Yeah, I don't see any reason why I would take them down until you guys are done with them. I mean, I'm going to say that you have every single one of them in writing in your packet. Like, it's not like I'm the world's worst person if I take them away.
If we were to take a test on this without like those,
You would have a ton of practice before you did it.
I'm sure she would do that.
As of right now. All right, y'all.
You said no test in this class. So.
Are you guys ready? All right, now, here's the deal. We're going to do an approach. You know what? Let's have everybody write down a first step. In fact, I would venture that almost every single one of you for the first piece of this will come up with the same first step. Hmm? Was I right that we all had the same first step?
yes. I think I know the second step.
You do?
I think I do.
I'd love to hear it.
We cancel out the cos, yes, and then multiply this sign.
Yeah.
Yes, Dan.
Oh my gosh. Yeah. Lane, I don't know that I ever plugged it in. There's a plug right behind that roller cabinet. But oh my gosh, you guys. Lane, you don't understand how exciting this is. You are the first person to try to sharpen a pencil in this room.
Yo.
Bro.
We should write it on the wall, write it on it so future generations know.
It's your pencil. Wait, sharpen his pencil.
I want
here.
you to-
I want you to sharpen it.
It's yours to sharpen. I want you to use it first.
Okay, so I want to go back to what Griffin was saying, because while Griffin, I applaud the idea of trying something. I'm not sure we want to try something we're not allowed to do. And so crossing out, so you want to cross these out and just call it sine squared, yes?
Ooh. Oh, wait, we're not do that because it's being added.
You can't cancel through a plus sign,
What?
so that's super annoying, right?
Sometimes you gotta break the rules.
But you know what we could do is we could call this cosine of x plus sine squared x over cosine x. Are we feeling comfortable with that? It doesn't change crossing out the cosine at all. Does anybody have any other ideas? There's some really good ones. Yeah. What are you thinking, Cody?
I'm thinking, what if we turn that cosine to 1 over cosine to be equivalent to secant?
We can't just change it. We could if you want to change that cosine to 1 over secant, but that's not going to help us. You guys. It's what? Mia, I can't hear you back up there.
It's gotta have the same denominator.
It's got to have the same denominator. And right now, so it would be great if I could have these together, but they don't have the same denominator. Is there, you guys with me? So, what do I do? Well,
It's a cosine times cosine over cosine.
that's what I would do, is cosine. I would take this first piece and multiply it by cosine over cosine.
Where did you get that cosine over cosine from?
I mean, this is the starting.
Okay. Hey, Griff. If I asked you to do 1 plus 2/3, you would change. What you would do is multiply that 1 by 3 over 3 to get a common denominator. Like, if you do that with numbers, that's what we would do. Are you comfortable with that?
Yeah.
So if I want this to have a denominator of cosine, whatever I do to the, I'm going to multiply the bottom by cosine. Whatever I do to the bottom, I have to do to the top.
Okay.
Is that, are you good?
It doesn't make sense, but it seems like a reasonable option.
Okay. You know what? I'm going to settle for that right this second. So, because like, then I'm going to have this like cosine squared x over cosine x plus sine squared x over cosine x.
Oh my god, wait. I don't understand how that's any more simplified than what we started. Oh wait.
It's, oh, this isn't. This is definitely not more simplified than that. I didn't say we were done though. Because now what happens? Yeah, go ahead.
I don't
You
know
roll
if
with
this
it.
is right, it just popped in my head, but since it's sine squared x plus cosine squared x, that is equal to 1 up on the thing, on the board. And then this would be 1 over cosine of x, but that is secant x.
That's 100% true. Trig identities definitely sometimes feel like you have to make it more complicated in order to make it more simple.
It doesn't seem like
Sometimes it feels like we're just pulling numbers out of like thin air.
We haven't used hardly any numbers. These are all expressions.
It's
These are
numbers
like,
in
there's
math.
not a number here. So this whole expression is equal to the secant of x. I'm trying to think if I can get there differently. I'll have to think through it.
This is so fun.
I love these. They're like one of my more favorite things. Yeah. These are one of my more favorite math topics to do. As you can see, they are not my favorite to teach. Because,
Well, I struggled last year trying to learn.
what?
You think this is fun now?
I do.
But that's because you know how to do it.
Sure. Duh.
It must feel good.
But like, I also know how to change a tire, and I don't think changing a tire is fun.
Some. I think that's fun.
All right, you guys, I know that you guys can do this one.
You would be wrong.
You have a lot of faith in us.
I do. There are going to be moments in which I have more faith in you than you do. But I genuinely believe in you right now.
Can we just do what we did here?
Oh, yeah, I do cosine. Oh, I did one over. I do cosine.
Wait, I don't know what that is. Wait, what's code?
Oh, because then you.
Oh, wait. Or cos. No, I think the cosine. Yep. Because then you can cross multiply.
Cross cancel, but yes.
I mean, yeah, cancel. What are you getting at? The bottom, cotangent. Wait. Just go with it. Just go with it. Cosine over sine.
What'd you get?
Sine over cosine.
Wait, I don't know.
Me-
Oh, I'm going. I'm cruising.
What's this?
Cosecant
of X?
It's cosecant.
Oh, wait. Yes, I did. I didn't do that. I sounded like I was
I like the division ones. Those are good. I can do that.
You can do that.
I was just proud of myself. I was proud of you.
You guys, how'd I do on this one?
Good.
I did okay?
Yeah.
And then, did you guys do cosine theta over sine theta times 1 over cosine theta? I did, but it's like cosine over 1 right now, and then when I flip it, it's 1 over cosine. Okay, and then from there, I got like a 1 over sine, and I get cosecant.
Glenn and I were kicked out of a couch.
Yeah.
By Mr. Ballinger, and it was really scary, and it happened out of nowhere, and I was just reading my book, and he was like, "Are you supposed to be here?" And we were like, "No."
Because we had study hall.
I understand. Oh, you guys, I still have a lot of faith in you.
Oh Lord. Wait, we should just turn cotangent. Oh wait, but it matters. If you make it.
Oh, you can get
If you make cotangent, you don't get rid of the sine. Get rid of the tangent. No, you can't because it's on the other side.
Yeah, that's what I was saying. If you do.
Oh, you're right.
I know.
Sorry.
That's okay.
Okay.
And then it would just be cosine.
Okay, yeah, but can you do it? Yeah, we can. We can turn tangent into sine over cosine. Look at you guys. Watch us be all wrong.
But then it's just
Sine x plus cosine. Oh, it's on.
I feel like I know what to do, but I don't know if I'm allowed to do it.
You can't cancel through plus and minus.
No, it's not canceling through plus and minus.
Okay, what do you think I should do next?
So, is there an equal 1 under the sign?
Like here?
Yeah.
Yeah.
Okay, so just like cancel out.
Yeah.
Fine.
No, because you can only cancel wait. Oh, I can cancel this sine and sine. Yeah. And this cosine and cosine?
Yeah, then
But where do we go from there? What do we do after?
Oh my god.
How we doing?
I'm still easily mad at I just want you to know there's a special spot on the site where students come out.
You think I came up with this?
Yes.
Wow, you think I'm really smart.
No, I think you're insane.
I wish I was smart enough to have come up with this.
What is this used for?
This is not gonna help me fit my couch.
Like, which job careers would use this aside from a math function?
Engineers would use it a lot. Probably not. All right. Man, you guys are gonna kill me.
Oh my god. Oh, this is so small. I don't have binoculars. Does he know everything on there? There's a comment coming tonight. That comes every 50,000 years. Oh, yeah. Wait, how did we do the other one?
Do you still have full confidence in us on this one?
I do have full confidence in you guys on this one.
I'll say the next two, I don't have full confidence in us.
Can't you cross it out?
I don't know what to do next.
Cross what out? The 1 over 10.
Well, yeah, hold on. No.
Tangents up there, where'd you get that? Oh, no.
How's my first step?
Cot turns into 1 over 10.
Miss Meister,
So I'm gonna do 1 over 10 times.
I got it.
Here, we put this one here. But there's for the second one.
So far, how we feeling? All right, and then
No, they're not.
Miss Meister, could you do cosine equals 1 over tangent?
no.
Wouldn't that be easier?
No, she's gonna watch tomorrow. We're doing extra after. I don't know if it's tonight.
Cosine's not equal to 1 over tangent.
I didn't make it up like it's coming.
No, you could change the cotangent to 1 over tangent. Yeah, that you could do.
Wouldn't that cancel out?
All right, question so far.
Yeah, what?
We did it the other way though.
We did it like,
We split the fractions.
that's why it looks.
Oh, so you did cotangent A times 1 over tangent A?
Yeah.
Yeah, but then we turned cotangent into 1 over 10.
Oh, so, and then you did this?
Yeah.
Oh, I didn't know where to go from that.
Okay. We're gonna. This is lovely. We're gonna kind of have two parallel approaches here. I love it. I love it. It's really my favorite part of this. Okay, you guys, which side should I keep going on for right now?
Left.
Left. All right. Okay. You guys are killing me.
You should do the middle one. Do the left.
Left.
Forward.
I think the 1 over
All right, on the left, y'all. I got cosine squared A over sine squared A, which I would call cotangent squared A. Because that's essentially cosine of A over cosine of A, or I'm sorry, over sine A
We could just take it as like
squared.
sine over sine and then just like.
Yep. If I look at this one, I get 1 over tangent squared A, which 1 over tangent is cotangent, so this would be cotangent squared A. I'm good with either of those.
Miss Meister, can we use the top right equation to say that cosine squared divided by sine squared equals 1?
No.
Divided by sine squared.
Good. That's not true.
But if you divide both sides by sine squared,
Where?
oh, never mind. It's a plus.
Is everybody okay? Man,
Miss Meister,
why? I feel like you guys are gonna get really mad at me for this one.
We already are. I'm shivering.
We're definitely not done. Yeah. There's 2 more examples. You guys, we can do this.
Let's rush through this.
Wait, which one?
We can do 2 more examples. No.
We need to. I encourage you to move forward and do more.
But you guys are recognizing that because so many people actually communicated with me that they were struggling, that's how we ended up pushing the puzzle. Like, when you communicate with me that stuff is challenging for you, I then listen to you and adjust, right? Everybody caught a little bit of that, right? That's what happened, and you, like the level of relief that you felt. You can feel that anytime you feel stressed in this class. All you have to do is, talk to me about it, because I'm a fairly reasonable person most of the time. Yes?
What would not be most of the time? What would make you unreasonable?
Is the answer to?
Did you say you had faith in this?
I do have faith in you for this one, yeah.
No, it's not.
Oh no, I was gonna do halfway of the first step is really what I was gonna do. You guys want halfway of the first step? Because this isn't, while not overwhelmingly crazy, it's not an obvious first step. But are you guys with me that to square something means to multiply it by itself? So I could say that this is sine x plus cosine x times sine x plus cosine of x.
Isn't it minus? Oh, never mind.
Is everybody good? Does that feel okay? And then it's been a long time, but we have done the distributive property where we call this this would become sine x times sine x is sine squared x. Sine x times cosine x is sine x times cosine x. I know that one really blew your mind. Okay. Cosine x times sine x is sine x cos x. And then cosine x times cosine x is cosine squared x.
Aren't those multiplied?
Nah.
Why not?
What do you think should be multiplied? Like you should be doing sine squared x times sine x cos x? Okay.
I got confused because there's the brackets on the equation under the original equation. Yeah.
Everybody good? Now, go ahead and do that for the second one of those. Yes, Theo.
Could we use the top right equation?
We will, but you can't yet.
But isn't sine x squared plus cosine x squared, or sine x plus cosine x squared, wouldn't the square be for both?
Nah, this is an algebra 2 thing. I'll let you and I talk that through a little bit more tomorrow, okay? But for right now, just believe me.
Okay.
And then I'll talk to you about the y tomorrow, if that works for you.
Yeah.
And guys, I got sine squared x minus sine x cosine x minus sine x cosine x plus cosine squared x. Is that what you guys got when you did the second one? All right, what else you see? So now that we've done that, anything jumping out at you?
Can we combine the sine cosine x, sine cosine x, and negative sine cosine x, negative sine?
Yeah, so if I could take this sine x cosine x and the negative sine x cosine x, what's going to happen to those two expressions? They're going to cancel out. And the same thing for the second of those. So really what I have right at the beginning, I have a sine squared x plus cosine squared x plus, and then I have another sine squared x plus cosine squared x. And then what do we know about sine squared x plus cosine squared x? It's 1 plus 1, which is 2, is my final answer.
Miss Meister.
Say that again. I love that it did.
No, because like someone
So much work for nothing.
that.
No, you guys are totally looking at this from the wrong mindset. In all seriousness, this is, you know how sometimes I get all nerdy philosophical, okay? Sometimes something really complicated is not nearly as complicated as we think if we take the time to deconstruct it and turn it into something simple.
But this
And
was
you
just
guys.
made out of thin air.
This wasn't made out of thin air.
No, like this specific problem was someone came up with that in order to teach.
Oh yeah, I did.
Remember what I just said?
I mean, I didn't come up with all the concepts of the trig identities, but I definitely made a problem. I've given you guys way worse of something that's. I think I gave you one last year where everything simplified down to 1 and it was this huge long expression. It was pretty funny. Yeah. Yeah.
So if the equation on the top and the equation like the third down
Yeah.
is those would be equivalent.
But they're equivalent. But okay. This expression
Yeah.
and this expression are not equivalent expressions. I needed this one to go with it so that these canceled out.
But if you got that, ultimately, couldn't it? Or is this what we're going to talk about tomorrow?
All right, guys, puzzle tomorrow. Bring your thinking brains. I mean,
Shocked me a little right now.